All right, in this video we're going to talk about sinusoidal functions. A sinusoidal function is a function of this form: y equals a times sine of bx minus c plus d. And then similarly for cosine. So these functions, right, are functions that are functions that have been transformed, like in college algebra when you talked about transformation of functions. So these are functions that just where some transformations have been applied to the sine or cosine function. Okay. Another word of or a word of warning about this is that in our book and assignments, the sinusoidal function is of this form: bx minus c, like so. If you refer to other texts or other websites, they may have a plus in here, which would, make things slightly different. It's equivalent to how we have it formulated, but there are certain things that could throw you off. So you need to make sure that, just if you're using another source, just double check to see if they have things set up like we do. And I'll try to point out some areas where that would be a problem. So, okay. So the basic idea is this: we have a function, and that's either a sine or cosine, and it's been multiplied by a number. The x has been multiplied by a number. You're either adding or subtracting on the inside of the trig function, and then a number added out here. And basically we want to say, is there a way to figure out what the graph looks like based on the values of these numbers a, b, c, and d? So I have a Desmos activity that you can kind of see here, and it has the basic form graphed out for sine and cosine, so you can choose either one you want, and then you can just set the values. The question is, and you can kind of use these sliders to adjust or change the values for A, B, C, and D. And so basically the question we want to answer is, what happens if you start messing with the value for A? How does that change the graph? And you can see really what it's doing is that the maximum points are getting higher, the minimum points are getting lower for positive values of A. If A goes into the negative range, it kind of flips everything around the x-axis, right? So like so. Okay, and then so we want to do the same thing for these other things as well. What happens when you change B? You can see that really kind of corresponds to a horizontal stretch or shrink. I'll set that back to 1, which is the value for the regular sine function. And then C, if I start changing that, what does it do? You can see that basically what that C does is it's shifting the graph to the right or to the left, so a horizontal shift. And then the D, the value for that number D, is shifting it straight up or down. Okay, like so. All right, so what we want to do is go into all of this in more details, and that's what we're going to do in the subsequent videos. So the first thing that I want to talk about is the midline of the graph. Okay, and so the midline of the graph would be the horizontal line that is equidistant from the highest and lowest points on the graph. Okay, so for these sinusoidal functions, right, there's some high points and there's some low points, right, on the graph. And so the midline, right, would be the line that is halfway in between those. All right, so for instance, in this one, the high points are going to be at 1, the low points are at -1. Halfway in between would be at 0. So, oops, 0. Oops, it's y equals 0. Sorry. And so the midline would kind of look like this. So the midline right halfway in between the high points and the low points. Okay. So that's important, and I usually like to identify that one at first because it makes it a little bit easier to do some of the other things that we need to do. All right, so the equation for the midline, so if I have a sinusoidal function, a sine bx minus c plus d, or a cosine bx minus c plus d, it's very, very easy to find the midline if you have the formula, because it is just y equals and whatever the value of d is. Okay, so that number d is also called the vertical shift, so you'll hear it referred to in that way. In the Newton problems, I can't remember if they have asked for the midline or not, but I'm pretty sure they will ask for the vertical shift itself. But to me, if you have the midline, it makes some other things about the other things that you're being asked a little bit easier to do. So let's go through a couple of examples. What is the midline of the graph? Y equals minus 4 sine pi x minus 2 minus 3. So here I have that function. Okay, and we can look at just the value, right, for d in this case, and we can see that it is y equals minus 3, right, is going to be the midline. All right, and you can see that horizontal dashed red line is halfway in between the high points up here and halfway between the low points as well. All right, so it's pretty easy to find the midline if you've got the formula and it's in the standard form. You just kind of read it off. One thing, if you, let's say you didn't have the formula over here, if they just gave you the graph, then how would you find where the midline is? Well, what you would do is look at the coordinates where the high points are, the maximums are. The maximums, right, are all at 1. They all have a y coordinate of 1. And then look where the minimums are. They are all at a y coordinate of -7. And so what you would do is just take the average of that. 1 plus -7. And then divide by 2, right? And that would give you the average of 1 and -7, which is -3. And that number, right, the average of two numbers is going to be the number that is exactly in the middle between those two numbers that you're taking the average of on the number line. So that's one way where you can find the midline if you didn't have the formula. With the formula, it's pretty straightforward as long as it's in the standard format, which this one definitely is. Okay. All right, let's try this next one here. I'll turn this off. All right, and so we want to find the midline of, let me turn the graph on here. So we want to find the midline for it, or vertical shift, however you want to call it, for this function. And you can see it's in the standard form right here. And so we can just say, oh, it's y equals 2. We can pick that off, and we can see that that is right in the middle between the high points, the maximum values, and the minimum values. Okay. Again, if you didn't have the graph or the equation, where you can just pick it right off and see, then you can just look at the average of the maximum value and the minimum value, right? So that would be the maximum values are 5, the minimum values are -1, and then you can divide by 2. That gives you y equals 2. So that's how you could get it from the graph itself. Okay. And just one more thing, going back to the vertical shift, you can see that that is really all this parameter d does, right? It just vertically shifts up the graph or down, depending on whether d is positive or negative, right? For positive values of d, everything gets shifted up, right? And for negative values of d, all the points on the graph are shifted down however many units, okay? All right, so that is how to find the midline of a sinusoidal graph.